start this again.
I can imagine that the licensing.
We'll start with AJ.
Are you nervous?
I'm very nervous.
Shaking.
I'm shaking. I am shaking. It's the caffeine. No, it's the nervousness.
Sweet. So please, if you are giving a lightning talk, take a look in Slack to see your order and come on up right before your talk. And then as well, I'm going to keep you guys to somewhat of a time limit of 5 to 7 minutes each. So if I come interrupt you, be nice, I guess. Cool. Well, first we got AJ.
Not ready.
Not ready?
I need to figure out how to get the screen to. I clicked on the wrong thing. Screen mirroring?
Yeah, you want mirroring.
I want me to change. Yeah, that's what I was trying to, I was trying to sort that out before I got up here. Cool. We're gonna do it like microphone too. I don't need a microphone. Do I need to use the microphone?
Yes, for the stream.
Okay, apparently I need to use the microphone. All right. Hold on. Let's do this right. Energy.
Water.
Don't do that to me, man. All right, we're gonna go straight into present mode. And slides aren't ready because I didn't even know if I was selected. How do I get into present mode these days? Where'd they move the present mode button?
Yes.
Anybody know?
I think this is good enough.
All right, it's good enough. Okay, so this is an IP address. It kind of looks like an IP address because you can tell there's an IP address in there. Everybody's seen one of these URLs, yes? Okay, come on. You've seen it. You've seen the AWS URL, the S3 URL. You've seen the IP. Come on. No, it's not just 3 people. All right, we're moving on. Okay, so this is an IP address. Okay, where do you see these kinds of IP addresses? Well, you see them all the time in web apps. You may have noticed that you see them in your database connections, like your Postgres app. You probably haven't noticed because you're Go developers, but Microsoft SQL Server does this. Another thing, Azure files, also known as Samba, all of these things can be reached via an IP address and a domain. Why are we talking about this? This doesn't make any sense. Well, first, I'm AJ, and yeah, that's me. And now we'll move on. There's a problem. There's only 4 billion IPv4 addresses. And the title of this lightning talk is TLS is better than IPv4. So now you have the context of the missing first slide. So there's 4 billion IPv4 addresses. There's about 8 billion smartphones. And there's about 50 billion websites. Okay, so just do the math, carry the 1. But wait, let's remember. IPv6 is going to fix this. Oh, that's not the right slide. Yeah, IPv6 is going to fix this because you've got 128 bits. So that's 32 bits for your ISP. Oh, and then your ISP takes the other 32 bits that are supposed to represent which networks that you can get. They're just going to take them all. Then you're going to get 64 of nothing, but you will get 1 usable address in your 64-bit address space from your ISP. So that's good. That might be 1 more than you got previously. But this is how the IPv6 breaks down. In theory, there's 64 bits for networking, and you should get some of them, like some of them. In reality, you get 1. There's 64 bits for addresses. In theory, you should get all of them. In reality, you get 1. So this means that but it's not a problem. Oh, I can't zoom in on this? Oh, I can. But don't worry, it's not a problem. IPv6 isn't a problem because Cloudflare is boasting that 15% of their traffic goes through it. So after, what has it been, 30 years, nobody uses it, so we don't have to worry about that. So that's a non-issue. All right, so we're gonna move on. And I don't know what order the rest of the slides are in because I just copied them in, so we're gonna roll with it. So actually, I'm gonna move this one here. This is my domain portal. And you'll notice here that there's only 1 actual IPv4 address that's a real IPv4 address that's publicly routable. And you'll notice that there's a bunch of other IPv4 addresses. How did I do that? Okay. So what if you could have all of your services that you want routable on the public internet just using IPv4? Just what if you could turn that 4 billion addresses into an infinite number of addresses? Well, it turns out that you can. And you only need one port to do it, and that's port 443. How can it be? Well, you may have heard of HTTPS, which is backed by a protocol known as TLS. And behind it, it has protocol. So in the old world, IPv4, we had port numbers, and you only had 65,000 of them. But in the new world, we have TLS, and you have what's called application layer negotiation, and you can have an infinite number of these names. And so if you look at TLS packets, you'll see things like HTTP 1.1, or H2, or WebRTC, or FTP, or IMAP, or POP3, or Jabber. Well, actually, it's called XMPP. But like lots of protocols that you know and love have a name, so you don't have to worry about the number. Everything can run over port 443. And then, not that one. Nope, not that one either. So anyway, the point of all this is, now let's go from franticness to actually making something that makes sense. I'm going to go back. So how this relates to Go, Go has excellent networking utilities, and I actually wrote a TLS router in Go. You could do it too. There are some gotchas to it, but every cloud service provider is using this. They're not using Cloudflare tunnels. They're not using these super complicated setups. On their side, they listen on port 443. They take in an IP address and a domain name, and they can route that IP address and the domain name into the private space, and you could too. So, sorry, this is a lightning talk. I don't have much to prepare and make it make sense. But if that's interesting to you, feel free to talk with me about it, because I think that it's great that we can solve our problems of making things routable on the public internet simply using a standard that's existed for a long time, is supported by all major providers, and you don't have to have really, really complex DevOps setups. You can have things as simple as, instead of putting in an A record for an IP address that you don't have, you can have one IP address, a whole cluster of things behind it, and then use CNAME records or similar techniques to be able to, or SRV records, et cetera, to be able to route stuff behind it. Sorry I took up so much time there. You're welcome. Good night.
Perfect. We can do one question.
I can do one question. Who's got the best question? Is it
How's your
you?
day?
I'm not answering that one.
Is it the same as like a virtual private cloud, like what you're trying to do?
Virtual private cloud is not exactly the same, but you can route things to a virtual private cloud through TLS. And that's what all the cloud providers do.
Thank you, AJ. That was awesome. Spencer Tuft. Is Spencer here? Great. AJ, do you want your laptop?
No. It just seems like it fits there really well.
Woohoo. All right, you should have a microphone. Thank you, AJ. This will be Spencer.
Yes, it is. Okay, let's get going. Don't ask me to set up my keyboard. Here we go. All right, I'm Spencer Tuft. I'm a software developer at BYU. Been there for almost 10 years now. 2 of those were as a student developer. We primarily, at that time when I started, were developing in Node.js. Before that, we were developing in C and PHP a little bit, and a few other languages, Java, Kotlin, were interspersed there. We do some Swift, but our main languages were the C, C++, and then Node.js. And that was a mistake, to say it bluntly. And these were the pain points that were driving us to change away from that. And in the last year, we made this switch to Go. we had too many frameworks to work with, and they kept changing too fast. Just today, I got a newsletter that said we have a new version of Next.js and Vite, so go upgrade to the next major versions, I guess, if you're doing that. But not for us. And ESM versus CommonJS, it just was getting out of hand. ESLint version 9, terrible, breaking change, and not compatible with any TypeScript plugins that you'd need. So a lot of TypeScript confusion started happening. Security fatigue. NPM has a lot of open CVEs, and Go has had way, way fewer. And that's a very attractive outlook for a language when your goal is longevity, like a university. Oftentimes, we touch an application, make some changes, and we don't touch it for months and months. And then a developer will come along and they want to add a feature, and they can't because the pipeline's broken, the build's broken, the tool chain's broken, needs to be updated. And now we're stuck in 2 or 3 weeks of maintenance before we can add a simple button to a page. So that just wasn't sustainable. So we needed I'm going to skip a few of these for time. We already talked about CVEs. Another attractive thing about Go that we really liked was all the built-in features. We don't have to battle about which formatting to use in our code anymore. Just use whatever is built in. The testing library is built in. Anyway, less bike shedding, faster onboarding. That's the gist for that. It was faster to start up our Go containers than our Node containers, so that was fun. We were faster at responding to requests than we were with Node. You can see we rewrote one of our systems, our registration cart system, and we were able to process 34,000 items in a minute versus 18 items in a minute. So that was fun. Yeah, huge. Backwards compatibility, again, along the lines of longevity, we really could not afford to have breaking changes in our ecosystem every few months. And when Go has this promise of backwards compatibility for version 1, we really like that. And we hope to emulate the same in our shared libraries, to not have breaking changes. Smaller dependency graphs, Go's clarity and minimalism makes it easier to read and easier to onboard new students. We have a lot of student hires at OIT, or Office of IT, and so we have better training outcomes because we're more consistent in how we develop Go code. Some of the student feedback was that Go felt more intuitive than TypeScript, and they liked that a lot of the built-ins. All of our students liked the built-ins, and then Node had lots and lots of packages for the same functionality, and that confused a lot of our students as well. They were asking questions all the time about, when do I pull in this library and when do I pull in that library? And they're supposed to accomplish the same thing, but they do it different ways. So lots of questions. Hiring, Node might have better hireability, but Go is steadily rising. And with the advent of AI into our public spaces, AI produces much more consistent Go code than it does JavaScript. Some of the drawbacks, we have some assertion libraries that there's a lot of assertion libraries in whatever language, but Go still has that issue. Not terrible to write your own little wrapper if you want. Decimal types, router quirks, there's some routing that has had some changes recently in the Go ecosystem, so we like those changes. We want to see more of those. And internal utility packages, auth, form helpers, sessions, we have to make some of those decisions either to adopt third-party libraries or make our own. But again, far fewer than if we were in a JavaScript ecosystem. Training materials became easier because you've got a lot of great training materials already in the Go ecosystem, thanks to its narrower scope. And we've started to even further narrow that scope by developing our own opinionated framework within our Go ecosystem, just the BYU packages and libraries that we use. So we bring them all into our projects consistently. We use the same tooling, and that's our framework, but it's just a narrower version of Go. We don't allow anyone to just bring in whatever package they want into our projects at BYU. They have to be approved. So and that's it for us. Our path forward is our Go framework, secure by default, maintainable, we're looking to the future with more sustainability and faster deploys. Thank you.
Spence? All right, next we have up is Zach Walton, who's going to talk to us about juggling.
Yeah, I actually need someone else. Is anyone good at juggling?
I can kind of juggle.
Kinda. Anyone else? Anyone really good? Come on up. Perfect. Let's get you set up. Morning, really quick. No, I did not make this presentation. This presentation is brought to you by OpenAI's Atlas.
Side note, I think Zach has given a lightning talk at almost every quest you've done.
I have, and they've always been about AI, and they've always been terrible, I think.
Okay.
But that's my favorite part about it.
Okay.
Am I even showing it, or am I?
Just plug in, did you? Okay, now it's mirror extend. Apple being Apple. There we go, you're on.
Okay.
You have a microphone.
I do.
You can see your screen in the back as well.
Oh, you're right. That did not go to the right screen.
So now it's extending, not mirroring.
Command P for this. What do you do for that?
Go to settings and switch to mirror.
I'm gonna give you drop it like. No pressure. It's not
Somebody's been dropping these all day. I can
I wasn't going to. It's already been done. It's just turning them into applesauce indirectly. Yes, you would.
You know your child. I don't need the notes anyways because I don't know the notes.
The new OS.
Yeah, so like I said, there's gonna be some interesting things. This is, oh yes, you're right. This is a presentation by Atlas. The way I did this, I had a conversation first, but this is kind of the point I wanted to talk about, the metaphor between juggling and how it makes me better at using AI tools. So let's go ahead. I'm sorry, what's your name? Porter. Porter is going to juggle for us right now. And as you notice, as Porter is juggling, yeah, and the thing that's really interesting about this is Porter's actually only doing two things. He is catching and he is throwing. Well, sorry, he is throwing. He is doing one thing. He's doing two things, catching and throwing. And the rest of it, gravity is doing and the apple is doing for him, the action. So this is what I wanted to talk about, is that sort of metaphor. And why would you never? There we go. The first step is to catch. These are great. In this method right here, I actually switch my agent to ask mode, typically if you have different modes for your agents. But right now, the first thing to do is you must gather context. You must be confident that what you're gathering, that you understand it and you can hold it. So that's when he's grabbing it. He's confident. He knows where it's going. He's grabbing it, gaining context. This is where I spend most of my time with AI. I ask not to clarify my understanding, but to build context to ensure the AI understands. I'll ask clarifying questions like, does this slide, and this is when I ask for this, does the image in this slide help convey what I'm trying to send? And the AI asks itself that. Let me think. You're trying to answer this, and then it answers that. So then when I move on to this next phase, it has context. And this next phase is the planning and the throwing. As you notice, as he lifts it up, this is the thing that gives it the momentum, but it's still the only other action he takes. Planning is crucial. If you are not using planning in agents and you are coding that way, you are probably spending more time debugging than you'd love to. And what we can do with this, and what I've seen others do, is you take this time, you take the context that you've asked it and you've brought in, and then you say, give me a plan. But not just give me a plan. It needs to have context accessible. I love to put these in markdown files. I've seen some do folder structures, but as this happens, you're giving it this concept to plan in. This isn't any real work. You cannot run any of this, but it is setting it up to break this down so that it can go well. when he is throwing it up, if he was throwing it to the left, he has no chance of catching it. He can throw it higher, but his actions have aim and they have momentum. That's what he's going for. Yeah. So he knows where it's going to land. And that's how we need to do our planning. We need to know where we need to get better and eventually know where this plan should lead us when we need to catch it again. After we plan, we just let it go in the air and it acts on its own. This is where AI is doing its own thing. It is actually planning. Atlas, when you see it do, it'll click around. It takes forever, but it is actually doing your actions. These are the tools doing the work. And the interesting thing about this is if we were to add one more ball here, a lot of the complexity, what changes about what he does? Does any other actions taken? Or is he still just hopefully catching and throwing, right? Same two things. Nothing changes except he has more to do. He has more tools in the air. So you can have as many AIs in the air. In fact, this is, I guess there was a slide before that. And here's the best part about this. When you're juggling, how often do you juggle? Okay, so it's not like juggling. So how bad did you feel that you dropped the apple? Was that a devastating moment? Is your life over?
A little bit, yeah.
I wasn't gonna say it. They were all thinking it. You're correct. No, but the main thing is nothing matters other than you pick it back up and you start juggling again. That is it. That is it. Nobody cares. Everyone thinks it's cool that you're juggling anyways. When you drop it, that was the expectation. We're good. And here's the interesting thing about juggling is the scalability, right? Again, what is he doing? He is catching, he's throwing. But if you want more to do, you have to throw harder and higher with the same precision, knowing where it's gonna land. And when you catch, you'll notice he actually catches it and cradles it even more. There's more momentum. So when you catch after you act, you still have to ask again. That's the momentum keeps going. When your agent finishes, now you are asking and ensuring that you and the agent both have accurate context. From there, you don't need to be juggling that ball anymore. You can toss it aside or you can keep juggling it if it has more processes. In fact, this is the style I did this in. And here's the rules to do this and kind of how I do this. The only rules are, you only have two hands and you're always catching and throwing. And those are the only two things you can do at once. But you cannot catch and catch and you cannot throw and throw. So you can only catch and only throw it once. But you can pass and switch off. So once he's done, he can ask on this hand and he can throw on this hand. But now this hand, it can't catch until it's thrown, right? And once it's free is the only time it can catch. So those are like the methods. You can ask, you can plan, but you can only have one agent in each of those. And once you're done with that, you move it through the cycle. Ask, plan, act, ask, plan, act. And that's how it works. And it keeps going through that cycle. I just lost the microphone, but that probably wasn't my fault. No, it's not. I think it's dead.
You think it's dead?
Well, hello?
No, switch them.
I think it has no will to live. I'm not sure. Thank you so much. These are my sources cited. This was all actually done in Atlas. I had a conversation with it. I had it literally just on the side. Oh, will it show me? This was, if it loads, it'll show you my whole, this was the conversation I had to make this slide. And it only took me since 9 o'clock this morning. It was not faster. So, but here's the thing. This is the important thing and why this matters. Dora metrics and plenty of white papers have proven that you are all slower because you use AI if you are coding with it. If you are only using that one tool and only coding, that instance of your coding is slower. You have to like look what it reads. You have to do all this stuff. The only way to get faster is to scale horizontally. You can't work twice at once. AI can. You can have many AI tools going. And if you're slower on just looking and reading and doing that, that's fine. You have 3 other things going on while you were doing your one job. You've never been able to do 4 jobs at once. Now you can. And that's where this magic is allowing certain things while they're acting, you can get more balls in the air and you end up doing way more than you ever were because you're not faster with AI, but you are able to be more multimodal and more multitasking. There you go.
Add applause. Awesome. Next, have Ulysses Flynn. Did I say that right? Awesome. He was going to talk to us about security, which will be very cool.
All right, can everybody? Hello. Okay. My name is Ulysses, and this is not your typical security talk in terms of software. This is more hardware. I love embedded devices and hardware, so this is kind of a talk about security. Biosecurity is not encryption, even though people like to pretend it is, but it's really not. So let me get started. I know since you guys all know about garage door openers, right? You guys are all pros. I'll give you a little context on kind of what happens when they invented garage doors. So the first models were kind of just really simple, like, hey, like, I'm gonna set some dip switches on this controller, I'm gonna set some dip switches on the garage door opener. Great, now I can push it and it opens the door. The problem is, that's not very secure, right? Because somebody can just capture that signal and replay it, and now they can open your garage door. So not too great. So what happened is the industry created this thing called Security Plus version 1. And so they thought, hey, we can fix this by just adding this idea of a rolling code. So basically, you would tell the garage door opener, here's the serial number of this remote, and here's some rolling code that we're gonna increment each time that you open the door. So what kind of ends up happening is that the garage door will check that serial number and that rolling code, and if things look pretty good, then it will basically say, yep, okay, I've recognized you, I'm gonna open the door. But what happens if you push the button a bunch of times, right? How many of you have been like, open door, open, right? Push that button and it doesn't work. So to kind of account for that, they basically don't check the exact count. They basically check like a range of like, hey, if this count is within 255, you're good to go, right? And then it increments the number. So while it's safe, it's really not that safe because who here has heard of a Flipper Zero or the Hack RF, right? Like with these devices, it's really easy for you to capture that rolling code, that serial number, and you can replay this. So like there's been attacks where like what happens is like if I'm out by your house, I can have a device jamming your button signal, and then I can capture that signal, and then I can use it to be like, oh, I have some good rolling codes that the user hasn't used. I can replay those and open the door. So that's kind of a problem, right? Like that's, this is better than nothing, but still not great. So what ended up happening was that the garage door industry said, hey, we can fix this. We're gonna create this new Security 2.0. It's gonna protect against this kind of attack. And what's funny is, from their own patent application, it says a rolling code transmitter is useful in a security system for providing secure encrypted RF transmission. Hey, encryption, we know what that is, right? That's secure. We do banking and, that we feel good about that, right? But the reality is different, right? Because even though they'll say the word encryption, doesn't mean they're actually using cryptographic security. So what's actually interesting is that if you look at the patent application, you'll see that it's just bit shifting, XORs, some bit inversions. It's just some magic, or like we like to say, security by obscurity. So there's a really cool repo that I have here on my slide, and it's basically somebody that's taking the patent application for the security system, plus done some reverse engineering, and now you can talk to these systems. So this is kind of fun where I basically did this at home. I have a Hack RF. It's like a little hardware device, software-defined radio. Downloaded this code and was able to capture, there's two numbers here. I don't know if you guys can see that. Maybe I'll zoom in more. Let's see if I can do that. Nope. Can you guys see this number here that says rolling and fixed?
Yep.
So the rolling number, that's the number that keeps getting incremented by 1. So basically, once I captured this fixed code, that's the serial number, and I have this rolling code, all I have to do is add 1, transmit that, and open the door, which is kind of what this command does here. It's basically, this is a transmit command, and it will go and open the door. So much for encryption, right? So much for security, because this doesn't really work. So basically what ended up happening is this Security 2.0 wasn't really encryption. It was just some special magic handshake that happened that is really easy to reverse. So as a follow-on, so I did that with an actual physical wireless Hack RF device, but the library also includes using the actual buttons. So if you guys ever used the buttons on the wall to open the door, it has wires going out of it. You could actually hook up an Arduino, hook up something to it, and control it that way. So that's what's cool about that is like if you do like any kind of home automation, like in the past, like most projects are like, well, just like solder up a relay to that button, and it's kind of janky. It works, but now with this library, you can talk to the garage door opener, right? So you can ask it to, hey, is the door open? Is it closed? Is there a sensor tripped, right? Go turn on the light? You can also even lock it, which is kind of cool. So what does this actually mean for the current state of the garage door security? So what we found out is that this encryption stuff, garbage, it's not really encryption. So basically it's like going back in time. Like, yeah, it's a little more secure, but it's still vulnerable to the replays attack, just like I showed you guys in the previous slide. The other thing is if you're a hacker and you love to mess with embedded electronics, you can fix this issue yourself. Like there are chips here. I linked this one from SparkFun. That is basically a little 128-bit cryptographic chip that you could add onto the garage door and your own custom remote to kind of make your door a little secure. The one thing that I recommend that it's really easy to do now is there's a lock button on your garage door opener. And then what that does is it disables the garage door opening with your remote. So it's a little safer. It gives you a little peace of mind at night or if you're going on vacation. But if it's me, just unplug the thing. If you're going to be gone for a long time, unplug it because it's not very safe. But yeah, that's my talk. Any questions?
Cool. All right. Well, thank you. That was awesome. This is very useful.
Everybody's gonna read it.
I just had a comment. I really liked your end statement where if you're gonna be gone for a while, just unplug it. That's like the highest form of security. Is just
Turn off all power to your house.
That's right. Awesome. Well, up next we have Brandon. Is Brandon in here? Oh, awesome. Come on up, Brandon. He's going to talk to us about write-only data code bases.
So secure.
That's awesome.
The lock doesn't mean anything.
It's so funny when you introduce, like, when IoT introduces it. See, and all of a sudden your toaster doesn't work.
Yeah, no, exactly.
All right, sweet. I can't claim to be the inventor of write-only code bases. I love this term. It came from one of my coworkers, Earl, who's here today. My name is Brandon Atkinson. I'm on the MLOps team, and we think a lot about AI on the MLOps team. And one of the things that has been sort of a surprising trend is this idea of a write-only code base actually exists now. Like, you can go in, you can generate a bunch of code, you can get a working app, and no person has ever read any of that code, and you may never need to read any of that code at any point in the future. Like, it just might be done. And that's really cool, but that does come with some problems, because while some code doesn't necessarily need to be read, that can't be true for all code. Like, a lot of the code that we ship, it's actually important that we understand it. AI means that we can ship way more code, way more tokens out into production. It's easy to generate code now. And so I think that's created somewhat of an interesting dynamic, because now more than ever, a developer's ability to read code, understand code, code literacy, in my opinion, is becoming absolutely critical in a way that it hasn't necessarily been in the past. And so as I think about this problem and how to grapple with a world where we have so much code that's being generated by AI, one of the things I think that's a powerful tool in our toolkit is PRs. They already exist. We already likely have flows built around the idea of reviewing code like this, and it gives that important check where we say, hey, this code is important, this code is critical, and at least one person, but hopefully a few people on the team, know how this code works before we roll it out. A, so that we can make sure it's not going to cause an outage or a problem, but B, so if that does happen, we have some people that know what's going on and can maybe work to fix that. So I just want to talk for a second about how you get good PRs. Building a culture of good PRs on a team is absolutely critical and will pay huge dividends. It will help you reduce the amount of debt that you take on. It will help you understand what your coworkers are doing better and reduce silos. I think it's really critical. And the most important thing for me when talking about how you make sure that you have a good culture of PR reviews on your team is to separate yourself from your code. You are not the code that you write. You're gonna ship bugs. You're gonna do dumb stuff in code. I've done it, we've all done it. That's okay. That doesn't mean you're a bad person. It's really important to separate yourself from your code because that allows for free criticism of code that needs to be adjusted. Makes it a lot easier to say, hey, I read through this code and I have some comments. There's some things that need to be fixed, some problems with it. Building up a culture where people understand a criticism of their code is not a criticism of them is like one of the bedrock foundations of a good PR culture on your team. Other things still apply, like small PRs are still good. You might be able to generate 1,000 lines of code really quickly, but maybe you shouldn't commit them all at once. Thinking about how your team is going to use the tools available to it to do PR reviews. What options are you going to use to do what things? What goes on Slack? What goes in comments? What PRs approve? How many PR reviewers do you want? Those things matter. Talk about those things with your team because establishing a good culture around that, I think, is absolutely essential. When you ship code now, I think it's more important than ever to think about how you are going to review your own code. Because again, you might not have written all of your code. It's very possible that you generated a bunch of stuff or even a small amount of stuff. You don't necessarily know every line the way that you once did. So check out a PR in GitHub or in GitLab or wherever you look at your code and like context switch into that UI. It's magical. Something about shifting from writing to reading will help you see your code in a different light. Comments. This is a thing that I've noticed is becoming really common. People will leave nonsensical comments that were generated by the AI that are completely unuseful. Yes, they don't affect the code, but they can affect readability. Please go back, clean up your comments. It can be really embarrassing, especially when the AI adds a to-do comment and you've missed it. It's like, hey, we should implement this. Don't give me a to-do comment that an AI built. Please read your code before you ask me to take the time to read it. Make sure you understand your code. Make sure you're running your code. Make sure you're reading through your code because it is frustrating for me as a reviewer if I can tell that you didn't really care about the code before you asked me to care about it. Woo! Woo! Yes, 100%. As a reviewer, when you get the code, remember that you are the second line of defense if something goes wrong. Your name is on that PR if something rolls out. So ask yourself some questions. Do I understand how this code works? Do I understand the structure underlying this code? Are the CI/CD checks passing? Am I prepared if this code rolls out and it goes poorly to jump in and start helping trying to fix it? Because I'm the next most informed person on the team. And honestly, you might be the most informed person depending on the state of the PR that came to you. So it's really important. Read and understand the code. And then some quick closing thoughts. This might not apply to everything, right? Like I want to make it clear that the one-off scripts you're writing, the throwaway code that you're doing, the data science stuff that it's just like, I wanted to build a pretty visualization and then throw stuff away. Like, you don't need to do this for every piece of code, but a lot of code is still important to review and understand. We still are finding situations where people roll out generated code and cause outages and cause problems. Like, good reviews are still worth it. And I think it's important as people who want to develop our skills and be valuable in the industry to recognize that some of the balance might be shifting. And it seems, again, to me, like the value of understanding, reading, being able to be a really good editor of code, a really good critic of code, is more valuable than ever. So if you want to be a valuable developer, maybe consider shifting more of your focus and time into being a good reader of code rather than a good writer. And that's my talk. Woo!
Awesome. All right, up next we have Hamza. Hamza?
Yeah, I'm here.
Awesome. Come on up. How do you say your name?
Hamza, yeah. You said it
Hamza.
right.
Sweet. Who's going to talk to us about red snakes?
Sure.
That's it, right? That's your title.
I meant the red snake for the skiing in the Cottonwoods, but yeah. So red snakes let's go for it.
Showing anything or?
Yeah, I will.
Okay.
I don't know why I'm doing this. I feel I lost a bet. I'm just. Should I allow this?
Oh, we have access.
Perfect.
That's Python.
Python.
Yeah, so I wasn't planning to present. I wrote this code, which is probably the worst code I've written like 2 years ago.
Yeah.
And I'm just outing myself here. So, for those who don't know, 2 years ago, a bunch of the skiing resorts in the Cottonwoods switched to having a parking reservation. We used to wake up at like 6 a.m. to get first come, first serve parking, and then they switched into like a parking reservation model, which was good on the long term, but that meant that you have to actually go on to the website and reserve the parking for the week before. So I didn't want to do that. It also meant that a lot of people will like go to the website at the same time and grab and try to get to reserve parking. That also meant that a lot of people did not get parking reservations. I wanted my bot to do that for me. So I wrote this script real quickly. Like I gave myself 2 hours to finish it, and the fastest way to do it was to just use a scraper, go in, get the HTML DOM, and like do whatever it needs to do to reserve the parking. One issue I had was that the calendar to choose the day from was embedded. So to circumvent that, is my code really small? Should I? I'll just. One more. Whoop. Not that. All right. So yeah, the calendar was embedded, so I did the worst thing possible, and I got the size of my web browser, and then I got the size of the calendar, and then for each day, like it calculated the coordinates on the page so that it goes in and presses the day off and then gets and then chooses that to like move to the next page and get that reservation. And it worked. So I just wrote a cron job that will just every week on Sunday at 3 p.m. it will go in, get me reservations for Saturday and Sunday, and I never needed to reserve ever again. I haven't used it for 2 years. Apparently, they did change their UI, so I can run it real quick just to show you what happens. But so you can see it. Whoop. Well.
Hey, it did something though.
It did something. It was working just 5 minutes ago before I came here, but it's okay. So that's what it did. I think what I wanted everyone to get out of this is, sometimes you just want to like write really bad code for your side project to use it by yourself. I think we like all try to like over-engineer stuff, and like it's fun. Like being engineers, we would like to over-engineer it. But sometimes it stops us from like actually pursuing and like doing our side projects. Just if it's gonna take an hour to do something, like just do it. Never have to get parking reservations. It's pretty dope. And I'm pretty sure a lot of us have these like small nitty stuff that would really benefit from automation that we don't do because we think it's gonna take a lot of time, but sometimes it's just real quick. So thank you.
Awesome, thank you. Next we have Josh Durantas, who's going to talk to us about chess.
Yeah, chess.
All right, guys. Hi, my name's Josh. I'm a software engineer at Vasion, and I was needing a side project to work on. I'd been in my career for a while, and I didn't want to do like a recipe database or anything like that. So I was like, let's do something I actually like. So I went with chess. I'd missed learning programming ideas from like making games. I remember the first time I made Flappy Bird, like in my Python class. I thought that was like so fun. You have to solve a lot of interesting problems, and it like builds skills that really carry over. So I wanted to do something kind of novel, but not like too novel. So chess is awesome. There's a lot you can learn from it, and Go is just the language we use at work, and I wanted more practice with it. But more specifically, like why Go? Well, when you have a chess engine, it needs to be fast, and at least compared to Python, Go is actually quite fast. There's nice byte manipulation support. There's a really enthusiastic community of people that love Go. Again, practice what I work on. I love the Go Gopher, and also I think Go's syntax, especially the if error is not nil, it's awesome. Very fun to work with. So another example, like you can do this in other language. I just like how in Go I can say a piece. Well, instead of like a struct, right? It's got all these attributes about it. A chess piece can just be a byte, right? I can have flags for what type of piece it is, whether it's black or white. A move, I don't need a move struct with a source, a destination, a target. I can just have a uint16. I can fit everything I need in 16 bits. I haven't found an application for this at work yet, but I do think it'd be very cool to have a microservice with a customer that's just 16 bits. But anyway. And then why chess, right? Well, it's so well documented. Thousands and thousands of people have studied it. I think there's millions of players these days. You can learn so much about the game. You can just learn how the moves work. You learn advanced strategies, all this other stuff. But more specifically, you can play against your own creation if you make a chess bot. So you can watch your child get better than you in real time. There's lots of algorithms you can learn. The way you have to speed it up, the methods you try, like chess has a branching factor of about 35. So in the mid game, there's about 35 different moves per state. So if your program is slow, you're gonna make like hardly any progress. Your AI is gonna be terrible. So even without making like an AI that knows chess better, you can just write better code, more optimized code, and that improves it as well. So you don't have to know chess, you can just know programming and make better chess bots. And then also, if you do multiplayer, you have protocol support, networking. You could make an online website where chess bots compete against each other, right? Go is a pretty good use case for that, and chess is awesome. And also, a lot of people think of Go as like primarily a back-end language, but there are libraries that will interface with the OS to make windows, draw objects, and I thought that would be fun to like take another look at Go as like a general language, not just a back-end language. So when you make chess, you can make the chess engine, but you can also, as a separate program entirely, make a chess GUI. And that's just an entirely different set of problems, right? Like I need to resize my window, right? I need to load these SVGs. I need them to not look terrible. I need to respond to clicks, stuff you probably haven't done in Go. And it's just seeing new and novel problems is always good for learning. And also, you can make the chess engine itself, right? So if you don't know, a chess engine is a stateless machine. It takes a board position and returns what it thinks is the best move. You can have it stop based on how many nodes it searched or some depth or just all sorts of things. But picture here Stockfish. It's an open source chess engine. It's the best one, actually. But doing this is where you're going to learn like AI techniques like alpha beta pruning, min-max search, transposition tables, all sorts of things that are just good programming and math concepts if you want practice. And then just, again, it's just more time with the language and things you probably haven't done before, but might come up somewhere else. Anyway, that's about it. I just think chess is a fun side project if you're ever looking for something. I'm doing it myself. I haven't posted anything to it in like 2 or 3 months, but I will get back to it. And yeah, I can do a live demo real fast. Nothing too fancy. but I've got chess. And it works. No illegal moves, all the stuff.
Awesome. Thank you, Josh. That was fantastic. All right, and then our last lightning talk is going to be Jonathan, who you will also hear again later, but he's going to give a short lightning talk as a teaser, I guess, for his speaking.
Oh, wait. Yes.
Yeah, that would be.
I promise it doesn't.
Well, Carson's-
No,
Carson's
the
gonna
HDMI
do the
works.
next two,
It
so.
does weird stuff with USB-C because there's a whole hub connected.
Yeah.
So it's often a lot weirder than just the screen.
Yes. All right, while I'm figuring this out, quick pop quiz. I think I'll figure that part out. Oh, yeah. Testing, okay. Pop quiz. I like to do this when I learn new things about Go. I ask other people if they know the same thing. What is the smallest package in the standard library? This is inspired by the way, this lightning talk is inspired by a conversation we had at Starbucks this morning.
That's why I'm not getting the answer.
You don't know the answer.
I don't.
I don't think you do.
Is it HTML?
No.
It's two functions.
That's not even, HTML in the standard library.
Yes, has two functions.
What, is that the full package path?
Full package, yeah.
But no, that's not the smallest.
Okay.
I might have overlooked that one, but it's not the smallest.
We're doing this by lines of code, by functions, by what?
So yeah, two in HTML, two files. Okay, you're right. Hang on, let me fix that first.
Why do you know that?
Why wouldn't I? Maybe you would talk on network. A little copy is better than a little two. So I thought I'd just copy the escape and also copy. That's all package.
Still end up copying.
No. The XHTML. There's template HTML. There's multiple HTML packages. There's three of them.
There we go.
Yeah, we're good now.
I can't see what I'm doing now.
What? You did two screens?
You can look at the back.
Okay, so HTML has two exported functions. That's what we're looking at right here. But no, there's one that has even fewer than that. Time/tc data has 0 exported symbols. It's only useful on import, but that's not what I'm talking about today. What I'm talking about is the CMP package. I should have done this differently. I'm going to try to mirror my screen so I can see here too.
Yeah, it'll make your talk easier later.
It's better to do it now than do the real talk, right?
Yeah.
Now I'm back in when you're ready.
Not detecting the Hunter girl.
Ooh.
That's what X wants you to do. They basically make them the same geometry.
Okay, so what I actually want to talk about isn't that. So TZ data, just for reference, zero exported anything. It's only useful as a blank import, if that makes sense. Okay, but we were talking about ba-da-bum-ba-bum. You don't need to see my errors. Where did the window go? Sneak preview, don't look at that one. Okay, CMP. So CMP only has 4 exported symbols. We were talking about with Carson earlier today that at the meetup here, the Go meetup, which I'm sure many of you attend, they're doing the standard library, and I was like, are you going to do a talk about CMP? Because it's so short, it's going to be a quick talk. So here it is, here's that talk. The CMP package, you probably only ever need to use one symbol from it, and that's the OR function. Has anybody used cmp.or? A few people? Hopefully by the end of this talk, you'll all start using it because it's really useful. And to demonstrate how it's useful, actually before I do that, let me talk about the other ones. Ordered, it's just a type that defines types that can be ordered, the built-in types that can be ordered in Go. You never need to use this directly, but I guess it's useful to know it's there. And then less and compare. Compare, you pass in 2 ordered values of the same type, 2 integers, for example, and it will return either -1, 0, or +1, depending on whether the first argument is less than, equal to, or greater than the second argument. And less does what it says on the tin. It returns true if the second argument is less than the first argument. But OR is fun. OR is the one that you probably should be using. To demonstrate, I wrote this little program in the Go playground. So the idea here, below the dashed comment line, is where the interesting stuff happens. If you've ever done this, cmp.or is going to be your friend from now on. So you have an input. Maybe it comes from a REST API, maybe it's user input, whatever. And you want to default to something if it's not set. So in this case, my input is just var input int, so it's the 0 value, which is 0. And then on line 13, you can say, or you can see that I set number equals input. On line 13, if number is 0, so it hasn't been set, then I set number equals the default value. And I've defined on line 9 the default value is 50 in this case. And then I print the final result, and you can see at the very bottom of the screen, the number is 50. CMP.or makes this ever so slightly nicer. Live coding is awesome.
Oh yeah.
It is.
And now there's the exact same output. CMP.or takes any number of arguments from 0 up to however many is a variadic function. So you can pass it 2 or 3 or 12 or whatever. And it returns the first one that is not the 0 value. That's it. That's the standard library CMP package.